Hello friend, I am Ramesh Bhise, Department of Physics, Honorable Balasaheb Jadhav, Art Commerce Science College, Ale, Tehsil Junnar District, Pune, Maharashtra. For the partial fulfillment of the UGC HRD Mumbai University organized refresher course in e-learning and e-governance, I talk on the scanning electron microscope. Now, first question arises in your mind that what do you mean by microscope? Microscope is a combination of the lenses which is used to produce a clear image of the object. Therefore, we have two types of the microscope. Number one is optical microscope and another is electronic microscope. In optical microscope, we use a simple light to focus over the sample and produce a clear image. In electronic microscope, we use electrons to focus over the sample and produce image of the sample. So optical microscope has two types, simple microscope and compound microscope. Electronic microscope has two types, same and tame. Now the question is that what do you mean by scanning electron microscope? So it is simply defined as it scans a focused electron beam over a surface to create an image. The electron in the beam interact with the sample, producing various signals that can be used to obtain information about the surface topography and composition. It works using a principle of applying kinetic energy to this to produce signals on the interaction of electrons. These electrons are secondary electrons, backscattered electrons, and diffracted backscattered electrons, which are used to view a crystalline elements and photons. Now we compare simple light focus into the microscope and electron focus into the microscope. So as we know that this is related with the resolving power of the eye. Now human being have a limitation to observe the image which is less than 0.2 millimeter apart from the each other, but we can use a combination of lenses. Those we can use to see the clear image of the object having the distance between two spot is less than of 0.2 millimeter. But white light has a wavelength is in the range of 400 to 700 nanometer. The average wavelength is near about 550 nanometer. Now as compared to visibility of this light, you compare it with the electrons, so that light microscope in white light having the range is in the range of 200 to 250 nanometers. That's why we use a electron microscope to develop whenever light is transferred through the microscope to produce a clear image of the object. Now here we consider one example that in first figure we observe that at the left side image shows the 2 points, those are so closer to each other and central spots are overlapped to each other. While in case of right hand image we observe that these 2 points are at the limit of the detection and two individual spots can be distinguished. Another example we use, suppose we use a optical microscope to observe the image and electron microscope to observe the image. We observe the two figures are not seen very clearly. If you use a scanning electron microscope, that image will be show very clear image of the object. Now the working of the scanning electron microscope consider five components. Number one is source of electrons, which we call it as a gun, electron gun. Second is column. Third one is electron detector. Fourth one is sample chamber, and fifth one is a computer and display to view the images. The schematic diagram of the scanning electron microscope is shown here. Now we see its working. As we know that electron gun is used to produce a high energetic beam that emits the electrons and focusing towards the sample passing through the three various chambers. First chamber considers first condensed lens, second condensed lens, and third final lens aperture. From these three columns, high energetic beam electrons transfer and focusing over the sample to produce a clear image. So in these lenses, these electrons are accelerated and focusing over the samples to produce a simple 3D image of the object. Now these electrons, whenever interact with the samples by focusing through the three columns, they produce a secondary electrons, backscattered electrons, and some other electrons. Those are the characteristics of the X-rays. These signals are allowed to detect by the some detector to produce a image. Now what do you mean by secondary electrons? So secondary electrons are a result of inelastic interaction between the primary electron beam and sample and having low energy than backscatter electron. Secondary electrons are very useful for the inspiration of the topography of the sample surface. Now the maximum resolution of this same is depends on the electron spot size and the interaction volume of the electrons beam with the sample. Typically, this modern full-size SEM provides resolution between 1 to 20 nanometers, whereas desktop system can be provided resolution of the 20 nanometers and more. Thank you all of you.